number 1 or 2, you can see the answers now. Let's go through the details here. First of all, on the very first line here, it creates a string object, stores ABC, 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 and then it stores that in A. So what is A storing? A reference to that string object. Once again, the object itself will always store ABC, ABC, ABC. String objects are immutable. You can't change what the object itself stores. You can change what the variable stores. You can change what A stores. Does our code anywhere in here, okay, let's stop that. Does any of this code change what A stores? No. You never see A equals again, right? So, now, move on to replace all. I've talked about this. If you read the description, if you do Java API string, and you read the description of the substring method, it very explicitly says that the substring method returns a reference to a new string that is the substring. It doesn't change the original. But that's what all these string methods do, they return a string. Because once again, you can't change the original, strings are immutable. So I'm saying this replace all does not change this original string because it can't. It produces a new string with everything replaced. Look, this code is worthless. Because if you were trying to actually change it, you failed. Because once again, your replace all produced a new string, but we didn't save it. And so when you get to here, you are printing what the object A refers to, which is the original string. And so that's what you see. The next one, of course, you can see, when we call the replace all, we store the results of that. And so you can see the new string in that case. But on number 2, what happens to the original string? It gets garbage collected. Java keeps track of whether we have access to an object or not, and as soon as we lose all access to the original an object, the garbage collector deletes it. But basically, that means it frees up that memory to the operating system. It's gone. We can never get it back. And so I'm saying on number 2, since B is now storing a reference to the new object, the original gets garbage collected. On number 1, we never stored a reference to the new object, so that's the one that gets garbage collected. Okay. Now, number 3. First of all, let me say, we generally will not use object as a reference type. Okay? That's not usually a good idea. We might use something like comparable, because strings are comparable, integer objects are comparable. That's a good reference type, but not usually object. Nonetheless, you should be able to figure out what this does. Look, the point is, if you look in the object class, you see a list of methods there. Equals method, string method, there's hash code method, a bunch of other methods. There is not an index of method. There isn't. Because that's a string method, right? So the compiler looks in the object class for a string method, finds it, but then looks for an index of method, and doesn't find it, so it doesn't compile. Now, how can we fix this? I mean, I could change the reference type to be string, of course, which would probably be best for this code. But what could I do here to fix it so it would compile? Put our typecast. Now, that by itself would fail still, because once again, your intent is to tell Java that C refers to a string object before you try to call the index of. So that's how you'd fix it so it would compile. Without the typecast, though, that's what you need to put, is that it's a syntax error or a compiler error. All right, now, the last one. And on this kind of stuff, it is tricky. I would draw the objects like I have on the screen, okay? And so before we get into that, though, let's look at the A class. How many instance variables does the A class have? One string, right? Right. Yeah. And then how many constructors? One. Does it have a default constructor? No. It just has the one you see. It takes a string as a parameter. And then it has the 2 methods you see. One more question. Is an A, would you consider an A object a mutable object or an immutable object, do you think? Or in other words, can you change what the object stores after you create it? Yes, using the setString method, yes? And so that's important. So as we go through the code, when you're done with the parameters, what you can do with it is going to vary depending on whether it's a mutable object you're dealing with or immutable. Okay? Now, let's go and, by the way, the B class, you can see it doesn't store anything. It does no data. It just has an history method that we're going to call. That's all. Now let's run the code in the main method. We create a B object that I didn't draw, but when we create the A objects, I would draw them like I did, show their instance variable, show what it's storing, okay? And then draw the references. Listen, this variable here, this 1 and 2 here, these are local variables. They exist only in the main method, okay? But what do they store? references to that A object, or those two A objects. Okay? Now, we said before, Java, when you call a method, it passes by value, is the way we say it. So what I'm talking about is here, you have, these two methods we're talking about created here. And what are they storing? References to the two objects, to the binary and byte object. So those references get copied into my parameters, which have the same names, but they're separate variables. And so what does this store? The same thing that the other one variable stores. What does this two variable store? The same that the other two variable stores. But once again, that's a one-time transaction. It copies the references out of these variables into these, which means, once again, everything that happens in here will have no effect on these original variables in the main method. Okay? Now, let's go through the code in the mystery method. Yes?
It says 2.set str x. Ours is different. We have a change method.
I changed the name, but it's the same.
So that's the same.
Yeah. Now, look at this. First line of code. What is 2 referring to, by the way? Byte, yes? So after this line of code, 1 and 2 both refer to byte. Or in other words, 1 was pointing to the binary string, or the binary A object, but now 1 points to the same thing that 2 does. So that's what you have now. Did it change the object? No. It changed the variable. So now when you do the print line, what do you see? Byte, byte. Because it prints what 1 stores, and then prints what 2 stores. Actually, it calls the string method for this object. So that's the first thing you should have is byte, byte. And by the way, is that how your worksheet reads? Yeah, okay, so go and write that as your first line of output. Byte, byte. Now, we do 2.set string. What does 2 store? A reference to an A object. I can do this. A object. And so you're calling this A object set string method. And what does it do? It makes its instance variable store a different string. So I'd come down here, and once again, it's not changing. Well, anyway, it makes it store hex now. So the A object is now storing hex instead of byte. So think about this. When you print 1, it looks up this A object and calls it string method, so you see hex. When you then print what 2 stores, you get hex as well, don't you? That's the next line of output. Hex, hex. The method ends. When the method ends, these variables, these parameters that existed only in that method, they disappear. Because they existed only in that method. That's gone. Now, we come back, we return, right? That's what happens when you leave a method. You return to where? To right after where you called the mystery method. Which means now we're doing this next line of code. So now we're looking at these local variables again. Did what the local variables store change in all of that? No. They were storing references to the binary object and the second object. That didn't change. Of course, the objects did change, or the second object changed. So what's the final line of thing going to be outputted? Binary hex. So, because, here, let me see if I can put this back. Come on. All right, so I'm saying, while I was still in the mystery method, I was using these parameters, and they both sort of reference to the second object, and the second object was hex, right? So when I print 1 and 2 here, I'm printing what this object stores, which is hex. So I see hex when I print 1, and I see hex when I print 2, because they're both pointing to the same object. My analogy that I always use, once again, is a house. I know the address of my house. I give you the address of my house, and you go paint my house. I will see the same color house because you painted my house. We both store a reference to the same object, right? That's what happens here. And so 1 and 2 are different variables referring to the same object, so they see the same thing. So that's why here it's hex hex. But once again, when you get back to the main method down here, that's this 1 and 2, and they're still storing a reference to the first and second objects, 2 different objects. The first, which is still binary, the second one is now hex. One thing that would have been nice maybe is before we started all this, if I printed 1 and 2 at the very beginning, I would have seen binary byte. Yes? And so, once again, the moral of the story is, we're dealing with mutable objects here. And so while the variables themselves never changed, they can't, they always refer to these two objects. The second object changed, that's why the output changed. All right, you're going to do the back now, and then turn it in.